Good morning, good afternoon, and good evening. My name is Rahul Singh, and I'm a principal at Anat. Um, we help people build global scale platforms, and we're partnered with Yugabyte. Today, I'm going to be talking about something that excites me, which is building smarter platforms with generative AI, and more specifically, retrieval augmentation, how it relates to databases. Um, you've already probably heard that Yugabyte is releasing the PG Vector as part of their next release. And again, if you're not familiar with PG Vector, that's okay. I think you'll quite understand what I'm trying to get at. This is a big deal. This is a huge deal. When Yugabyte came to the game with distributed Postgres, that was a big game changer. And now with PG Vector, it makes it even that much better. The next frontier in AI is prompt engineering. Computer languages have they've gotten better over time, and now the ultimate computer language is language, because the computers understand language now. I want to take a moment to thank our customers who've given us gainful employment and opportunities to learn and serve them to do cool things. I actually organize a ongoing boot camp. We've done a series that was 100% virtual. If you're interested, just go to kona.io/bootcamp and put in the survey response so we can figure out when to do the next one. The agenda of the bootcamp is basically a much longer version of what I'm about to do today, which is understanding the strategy and theory behind large language models, the design patterns that are there that one can use, looking at no-code, low-code, large language model application stacks, and then, of course, building out your own chatbot with LLM with your data. Today's agenda, I'm going to try to give you as much as I can in what is prompt engineering. If you're not heard about it, I think you'll find it interesting. If you have heard about it, I think what I have to say might be interesting to you as well. And then retrieval augmentation, which is the pattern in architecture for in LLM application architecture for how to make your application use your data so that it's not just using the data that's been trained on previously. Before LLM engineering, machine learning was hard. We had to do a lot of data operations and to get the data somewhere. You have to do some featurization. You have to manage your models. You have to have a model registry. And once the models are trained, you have to serve them somewhere so that your applications could use them. Now, making intelligent platforms is a lot easier. Why? Because the optional portion, the hardest part of this, which is machine learning training, is now optional. You still have to do your data ops. You still have to have people that are making software talking to APIs, but in the middle, you don't necessarily have to train your own models. You can use the open AI, Cohere APIs that are out there, or you could use some of the open source models that you can host yourself, and they're pretty good. And when you augment it with your data, they're really good at what you're trying to get it to do. And if you really wanted to, you could fine-tune those models to be better at your data set. And that's a very advanced topic, but it's optional. You don't have to do it. And at the crux of everything here, to make it all work, the skill that is new, relatively new to a lot of people, is prompt engineering. So we'll go over what prompt engineering is, and before that, we'll just do a quick review of how large language models work. And then once you have an understanding of what a prompt is and how it works, we can then go dig deeper into, well, how can you use this to make a legitimate application? LLMs, they predict words. They're trained on huge corpus of data. And they generate new text as a completion. So when you're giving it words, it's finding the next probable word. And the reason it's so good is through obviously billions and billions of neurons in a neural network using an architecture called a transformers architecture. Again, that's outside the scope of this talk, but you can use LLMs to do lots of cool things as it relates to text. You can do language translation, you can make chatbots, you can create content, anything that a human would be doing with text, large language models can do as well, including writing code. At the end of the day, what happens in LLMs is that when you're making a request, it's narrowing the possibilities of what could come back. So if you can imagine, if you type something, it could give you chaos, meaning random characters, but it's not doing that. So it's kind of giving you stuff in English, right? But it could give you garbage in English. It could give you random words in different order, right? And so there's a smaller universe of words out of the infinity of words and documents that come back that are probable responses in language, in a particular language like English. And then there's a smaller version of that makes sense. And then there's a smaller portion of that makes sense for you. And so when you make a prompt, you're narrowing down the possibilities to get your answer that makes you happy. And it may just look like a chatbot to you, but that's all that's happening, is you're just giving it a narrow set of words to then continue to predict on. And if you happen to put your own data into the mix, then you can get the machine to do stuff with your data. And you can get it to understand content and create knowledge. A prompt, at the high level, you give it text and it gives you back text, right? And they're like magic spells, and you'll see that in a second. If you know what to write, you can get it to do a lot of cool stuff. And there's lots of videos, content out there on prompt engineering. I'm not going to bore you with that. But what is the benefit of prompt engineering? Well, it's very accessible. You don't need to be a machine learning engineer or data scientist. You could just be a regular knowledge worker that understands what you need, and as you would give it to somebody on a Slack message, hey, I need XYZ, you could potentially give it to LLM and it'll give you back a pretty good answer. And you don't need to spend millions of dollars in training it, because the models that are out there are pretty cheap, or you can even do your own open source models, hosting them. Wouldn't really recommend it if you're starting off. Just get an OpenAI key, right? It's like pennies per request, and they're pretty fast, and they'll continue to get cheaper. The other thing that's really cool about prompts is that they're repeatable. If you have a prompt structure or a prompt template, they can be used like a computer function. Important part about a prompt is that you have essentially a task description, the actual input, what you're trying to do with that, what the task is supposed to work on, and then an output indicator. So an example is, this is a conversation between customer and profile, helpful customer service agency, question for the customer, and then the response would be, something that the LLM get back. So in this case, what it's happening is that you're telling the LLM, this is a conversation between a customer and a polite, helpful customer service agency, and then the question of the customer, and then you put what the customer has asked, and then you can say the response from the customer agent should be like this, right? And then you send it to the LLM, it's going to give you an answer back that's hopefully very polite and helpful, and it's related to the question that the customer actually asked. So whatever the customer is asking for is your input, and everything around it is the prompt template. It's like a function, right? So you have your instruction, you have your context, you have your input indicator, you have your actual input, and then you have your output. So it's kind of like there's an output type, right? Which is the return of a function. There's a name of the prompt. I would say just in our case, we don't name prompts, although in semantic kernel you can. And there's input and context, and there's instructions on what to do with that. But we don't write it as code. We just write it as English language. And you can do different things. So for example, you can classify the text. You can say classify the text into neutral, negative, or positive. Here's the text indicator. Here's what the input is, and then the sentiment, which is the output indicator, and it'll give you the sentiment without you having to go download a natural language model, right, or a sentiment analysis model. In this case, you can say extract entities such as people, companies, places from HTML. Here's the input indicator. Here's some HTML, and then this output should be JSON. Give me, and it'll make a pretty good structure for you. And you can also define that structure if you really want to. So The powerful, bit about this, I think you will understand, is it's not that the LLMs are super smart, is that they're only as smart as you are. They're only as smart as the questions you ask them. And what people have found, that there are some magic patterns, and you don't have to reinvent the wheel. You can just borrow them from other people. Okay. So few prompting techniques that people are using: summarize X, infer Y, transform this into this versus this, expand this. Here's a summary, make this into a document, or here's an outline, make this into a document. And then you can do a sequence of things together programmatically if you wanted to. So we call it a super prompt, right? Super prompt would be create topics on a subject. Another prompt would say take these topics, make an outline. Another prompt would say expand each outline into a paragraph, right? So you can chain these things together for you to basically get some cool output. And then what we're going to talk about today, which is connect your prompt, which could include all the things that I just said to you, and connect it to external data, your database, your index, right? So quick thing related to Yugabyte. Yugabyte already has Postgres compliant data store. And guess what? Your prompts can take a natural language query and make them into SQL. So that alone could be used against Postgres. Now, we'll get into how you can do an SQL query, get the data back, and then send it to the LLM to summarize or whatever. That's kind of the next step. And the next thing that Yugabyte just added is PG Vector, which is a type of index that is really useful for AI, and we'll get into that. There's tons of prompting techniques. Zero shot, few shot were the first types. Chain of thought is really cool because it's really simple, but it's really cool. React, not the front end framework, but it's called reasoning in action. It combines some things like chain of thought with external systems, right? So chain of thought, what they found is that if you're asking a question, sometimes if it's like a math question, it'll just not get it right. But if you say for chain of thought, hey, this is how I would do it, right? I would break this down and I would do it like this, and this is the answer. The next question you give it, it's going to try to mimic that step-by-step process. And actually that works. And what other people found was you don't even have to put an example. You could just say, here's my prompt. Let's do this step by step. And that improved the outcomes tremendously, right? That's a magic spell. And then with React, what it actually does is it does that step-by-step process, but it breaks down the question into smaller questions, and then it can determine whether the LLM is the right tool for the job. If not, it can do an outside retrieval, like an API call, a database call, an index search, you name it, and that can come back. The other thing it can do as an action is it actually make API calls to do something for you. So if you can imagine, it's not just able to generate text. You can say, I want you to create 5 servers on AWS, and if it has been given the context of how to access AWS APIs, it can create the code to create those instances for you, and then you can execute that code. So retrieval augmentation at the core is, either using your data as is or using your data vectorized. And then there's some patterns and architecture that we can build around that. So it's pretty simple. What is data/retrieval augmentation? It's basically using the core principles of information retrieval. We get the data that's not in the LLM, that it has not been trained on. And for example, if you talk to ChatGPT about what happened today, it won't know because it hasn't been trained on today's data. It's been trained on whatever the last build was. We can give it more context to answer a question. So if you wanted to ask questions about your customers' previous interactions with your company, you could pull some stuff from Salesforce and put it in there, and it's going to be contextual related to what that data is, not some random thing that it makes up. It's called hallucination. So, but we do have to manage these things called context length limits. So they're getting bigger and bigger. But it used to be you could only do 4,000 tokens, which is like 3,500 words. Now it's like 8,000 or 16,000 or 32,000. Some of Cohere, for example, has a token limit of 100,000, which is like huge. It's like a book. And when you do this, you're basically enhancing the capability, right? And you're basically making this a dynamically learning system without actually training the LLM. You're fine-tuning the LLM's output based on what you're giving it. It's not like a fine-tuning of the model, you're just fine-tuning the data that it gives back to you. React is the beginning of this whole transformation in our industry here. That paper basically spawned so many frameworks that do this for you, so that you don't have to program this interaction structure, right? And that, again, you don't have to know how the whole React framework works. The React paper explains this. Just understand this picture, which is it's taking a question and it's breaking it out into thoughts. And those thoughts get broken into actions. And eventually it takes the answers of all the different actions and it summarizes them for you. So, using information retrieval LLMs, you're going to be, writing code or using a framework that takes the user's input or some input from another, like an API. Or it could be the API itself, or the API is getting input from an API call. It then can talk to a search index, a SQL database, an API, get that data, construct a prompt around that data with the query, right? Send that prompt to the LLM, get an answer back, and then format it and send it back to you. That's what retrieval augmentation is in a nutshell, okay? So user has a question, or it's an API that's making an API call, so the input is a query. Your framework, whether you write it or you build it yourself, it can request data, retrieve it, construct a prompt. We will say that's an augmented prompt. Send the prompt to the LLM gets a response back. Framework intercepts it, sends it back to the user, right? And again, it doesn't have to be a user; it could be a system that's calling an API call. So in this case, your data could be Yugabyte with the Postgres SQL as the way that you're getting your data or retrieving your data. Or it could be PG vector. But there's a little bit more nuance to how you deal with a vector database. And that requires vectorization. Vectorized data augmentation is slightly different. It's similar to search index data pipelines. We take data, we pre-process it into embeddings using a large language model. You can use OpenAI. There's cheaper ones for embeddings, and then there's open models as well. And then you take the embeddings, which are just numbers. It's a numerical representation of the words you gave it. And you store that in a vector database, right? So that's a pre-process. Then the next time somebody wants to ask a question against your data, the framework intercepts the question, embeds it with the LLM. So it takes your question, vectorizes it. It then uses the vector of the query or the question, finds similar documents from the vector database, and then sends the metadata or the actual text into the context as part of an augmented prompt. And then the LLM gives you an answer. And when you take a look at it visually, I'll get to that in a second. But when people ask, like, what is it about vector databases that's so important, and why is it so useful in AI? Well, it's because the models are trained on vectors. Everything, images, audio, video, text, it eventually gets vectorized and run through the vector model, and it outputs vectors. And so the transformers architecture, actually, there's an encoder and a decoder. So it encodes your question, goes through the system, it gets back the vectors that it thinks are the right answer, and then it decodes it into words for you. So it just kind of makes sense, right? Use the same vector embedding encoding structure as you're using in your LLM in the way you're indexing it into your vector index, and you're going to get pretty good results. So the pre-process of a vector information retrieval augmentation is you take your data, you have a framework hopefully that you didn't make yourself that takes every piece of data, maybe splits it into smaller documents, gets the embeddings from an LLM, and then stores those in a vector database. In our case, it would be PG vector. And then once it's in there, the second part is, again, very similar to the retrieval augmentation, but with this second step in here of after the user asks a question, you embed the question, you get the embedding, you find similar documents from the vector database, and then you put that into the prompt, and then you give it to the LLM, and the LLM gives it back to you via the framework. You could technically also use a similar pattern with just SQL, where the question gets converted into an SQL using an LLM, and then as that SQL is executed against the vector database, and then that comes back to you, and you put it into your augmented prompt. Augmented prompt goes through and gives you back the answer. Here's a real world example. So imagine that you have Google Docs, CRM, and you export that into some sort of flat text format. You drop it into Google Drive. You have your Slack messages. Llama Index is a framework that works with different types of connectors to get that data into a document store and a document index before basically chunking it, summarizing it, and then embedding it into a vector database. And these are optional steps, by the way. Chunking and summarization are optional steps. Once it's in the vector database, when the user then asks the question, we embed it. Actually, Llama Index takes care of that. It automatically takes the question you ask it, embeds it, gets the similar data, similar documents, sends it back to the LLM, gets the response, and sends it back to you. What are the LLM frameworks out there? Well, there's Llama Index, there's LangChain, there's Semantic Kernel, and there's more all the time. New ones coming all the time. People love reinventing the wheel in open source land. I'm not saying that's a bad or good thing. Competition is good, and what we'll find is that these things can work together, right? They're not exclusively good at just one thing. Some of them have overlap, but if you think about Llama Index, it's really good at document indexing and retrieval. LangChain can do more, but you can use LangChain with Llama Index. Semantic kernel is really cool, has a much better architecture. You can write your prompts as what they call semantic functions, and different versions of semantic kernel, the C# version, the Python version, can use that semantic function in the same way. So that's kind of cool. But if you're using the Python version of semantic kernel, you can use LangChain, you can use Llama Index, because they're both written in Python. Before we use a framework, I would just say that you can just use direct API with Python or Make or Bubble, whatever you're using, just calling the LM yourself. Nothing stops you from that. An example would be you have a Bubble app talking to LM, or you have your web app talking to your API, talking to your LM API, right? For background process automation, again, you can use Python with an Airtable or another database. And I mentioned that because Airtable gives you a GUI, but you can use SQL Server as well, right? But let's just say you had a business process you wanted to automate, right? You'd say, user, fill out this form. Your Make automation or your Python automation can pick it up, and then it can do something to execute that process. The pros here is that you can quickly automate prompts as processes, very quickly, as long as you're okay that you're not doing outside data, but you're just doing basic input and output. It lets you validate the prompts. Cons in no code is that you're doing lots of point and click. And then retrieval augmentation is hard in here. You could do it, but it's hard, right? And another thing, I don't know if you can see it, is that it's hard to do what's called agency. An agency is it acting on its own, right? So that's kind of hard inside just doing it yourself. That's why people have built these frameworks in the first place. So, for example, if we wanted to use LangChain, we could have LangChain using our LLM API with other third-party APIs, like Google Search, and your own API. And you take this whole enchilada, you can then add it into an automation. You can make it into an app. You can even add Llama Index to it as a tool in its tool chain. Okay? Pros, agency is relatively easy. Retrieval augmentation is easy. LangChain is implemented in Python and JavaScript. There's a Java version that somebody's working on as well. The cons are that you really need to know the concepts. it's easy to write bad code. And then sometimes the agents will kind of act on their own, and they don't do what you want because they're just, again, it's a conversation for another time. So with LangChain, for example, you can embed the document, put it into a vector database like pgvector, and then when a user asks a question, you can do the search on it, get the data back, send it to the LLM, right? LangChain allows you to do that. It has connectivity to Postgres. It has connectivity to pgvector. Llama Index, same thing, your data, your API, the LLM API, and you can make it into an automation, your own app. You can add LangChain to it. Retrieval augmentation is easy, relatively easy to use. If I remember correctly, there is a version of Llama Index now that's written in TypeScript. I don't know how robust it is, but it's also, it's available in Python, which most people use. What I think it's both the pro and con is that it's purely focused on index management. It doesn't do a lot more than saving data and retrieving it. It can do some agency, but it's hard to do it by itself. You kind of have to use something like LangChain for that. So for example, in Llama Index, they actually have a chain, quote unquote, or it's like a store that when you ask a question, it can try to make it into a SQL statement, ask a database with SQL, and get the data. It can simultaneously, or in addition to, ask a question using a vector embedding and get similar documents from a vector database. It can then merge that and give you an answer. And with Yugabyte, you've got both worlds, right? You've got the Postgres layer and you've got the pgvector layer. So you don't have to have two different databases. Otherwise, you would have to have two different databases. Semantic kernel, not the winner of the popularity game, but definitely the winner in my book for just amazing, complexity that's distilled in a very simple way. Same type of pattern. You can do whatever you want. They call it connectors. They have better vocabulary, connectors, scales, memory. It's available in Python and C#. It's backed by Microsoft. Cons, you could get lost in the .NET. C# needs to be compiled. It's not as cool as LangChain and Llama Index. But what's cool about semantic kernel is that it, out of the gate, has this idea of memory, connectors, and skills that are easy to explain to developers. And it can work with Llama Index, and it can work with LangChain, it can work with Java. It's called a native function, right? So very powerful. This is what the Microsoft Office Copilot stuff is being built on. So worth a look, right? And whenever you need to get data from memory, you can use Postgres or the pgvector layer in Yugabyte. Key takeaways: prompt engineering is a new skill. Learn it. Data engineering, you know this stuff. If you're working with databases, you know this stuff. Software engineering, you know this stuff. I would say go try it out on your own. Make an OpenAI account. If you don't have a paid API key, get a paid API key. They give you like $18 a month. Use the open frameworks, do the demos, and you will learn a lot just doing the demos. You can go to Google and look for prompt template tools. There's lots of open source projects. There's Discord channels. And there's a site called ShareGPT with lots of really great prompts that you can try out there. There's open source prompt data sets that you can put into your application. And there's tons of Discord channels, and we have a Kono Discord channel. If you fill out the survey, I'll get you invited there. But that's where I learned all this stuff. That's where our team has learned all this stuff. I think that's where everybody is, on the bleeding edge, just playing around on, right? So get on the Discord channels. And if you need any help with any of that stuff, you can hire us. Thank you so much for letting me speak about something I'm very, very passionate about, and hope to see you on our Discord channel. Thank you. And thank you to Yugabyte for having the DSS.